All right, so now we just talked about sine and cosine, so you do the tangent ratio exactly the same, except with tangent, you're not using the hypotenuse, you're only using the opposite and adjacent sides. So again, the tangent of an acute angle. Once again, you cannot use the right angle as one of your angles when you're setting up a ratio. So you look at the acute angle and it's going to be the opposite side to the length of the adjacent side. And again, adjacent means that it's the side that makes up one of the sides of the angle. Okay, so you're going to use this calculator the same exact way. So what do I mean by this? If tangent A, if this is what we're looking for, that would mean you have the opposite side here, and because this shares a side, that would what we call the adjacent side. Use your calculator to find these, so you're going to hit tangent 25. You don't need to hit, and then you hit the equal sign, and you will arrive at a number. And the number you arrive at is 0.4663. And tangent 53, you do the same way. You just type tangent, you get a parentheses, you type in 53, close your parentheses, hit the equal sign, and you should get 1.327. Okay? When they give you the ratio and you're trying to find the measure of an angle, that's when you hit second, tangent, and you should see this little -1, and then you type in the ratio or the fraction or the decimal, whatever, and then hit your equal sign, and you should get a whole number for sure this time, greater than 1. So that angle is really small. It only has 5 degrees. And then if it says find the measure to the nearest degree, I don't need any of this information, because to the nearest degree is the first number to the left of the decimal. Okay? And here I'm going to go second. I'm looking for an angle, second, tangent, -1, I type in my ratio. In this case, it's a decimal. Hit my equal sign, and you end up with like 29.9996. Well, it says round to the nearest degree, so this 9 tells me to round this up. So it would be 30 degrees. For this last problem, I'm going to draw a picture, ABC, to help me with my ratio. There's my right angle. Now, if BC and AC are both 20 degrees, I know that C has to be in the middle here, because these are both legs. If it said it was a hypotenuse, then my C would be over here. So BC, I'll just say is 15, and AC is 20. Okay? And I want to find angle A. So this right here is angle A. Now notice I don't have the hypotenuse. The hypotenuse is not information given to me. So I'm definitely going to use tangent. So the tangent of A equals, and the ratio I'm going to set up is always opposite over adjacent. So 15 over 20. So I hit second, tangent, you get -1. Make sure this is in parentheses. Hit your equal sign, and you should get 36.8699. Well, rounding to the nearest degree, this tells me to go up to 37 degrees. So angle A is 37 degrees. If I wanted to find angle B, I could just do 90 minus 37. And so angle B is 53 degrees. Just saying, you know. All right, so let's do some example problems from your homework and go from there. Your lesson 35 practice should look like this. I'll just do like the first problem in each category, or the first couple problems in each category. So we'll do number 1 together. The first thing I would do when I'm working these problems out is I would actually label what this stuff is. So the angle of interest is right here. This is my hypotenuse, and this is opposite. So if I have opposite and hypotenuse, I'm going to write up here, so okay, so opposite and hypotenuse, I'm looking at sine. So sine of 73 equals 15 over x. These are going to flip-flop because if I multiply this side by x, and then I divide by the sine of 73, I'm going to divide this by the sine of 73. So to work this out, I'm actually going to type in 15 divided by the sine of 73. These are going to flip-flop positions. That's just solving equations. And you should get about 15.7 degrees. It says round to the nearest tenth, so I'm going to leave it like that. Let's do another one like that. The one right below it. All right, once again, this is my angle of interest. This side here is adjacent, and this side here is opposite. I don't know the hypotenuse, so this is going to be tangent of 26 equals opposite, which is x, over adjacent, which is 17. Now this one's not going to flip-flop. This I multiply both sides by 17. So x equals the tangent of 26. Make sure you put it in parentheses, times 17. And if you type all that in correctly, you don't want the 17 to be inside the parentheses or it will be the wrong answer. You should get x equals 8.3. I'm sorry, I don't know why I said this is degrees. It's not degrees. Going back to that. Okay, so notice the difference. If x is in the numerator, you multiply these two. If x is in the denominator, you flip-flop and you divide these two. All right? I just wanted to show you that. All right, down here we're going to find the measure of the angle. When you have to find the measure of the angle, you do have to do second. So for down here, you're going to put second and then whatever the thing is in your calculator. All right. So this is the angle of interest, and I'm going to look here. This side is adjacent because it's one of the rays that makes up that angle. And this is across from the right angle, so that's my hypotenuse. So if I have adjacent hypotenuse, I'm looking at cosine. So the cosine of x equals 24 over 55. You should get 0.99999. Oh, no, I'm sorry, because I did it wrong. I forgot to put cosine -1, so you should get 64.1 degrees. Now it says to the nearest degree, so it'd just be 64 degrees. Let's do another one of those. Number 11. All right, this is my angle, so I'm looking over here. This is opposite and hypotenuse. So this is going to be the sine of x equals 19 over 33. And again, I'm going to hit second sine. 19 divided by 33, close my parentheses, hit enter. And I should get about 35 degrees if I round it properly. Okay. Let's go ahead and try one of these. These are reminders of, they should look familiar to you. This is lesson 34A, excuse me. So if you don't recognize this, you want to go back and review 34A. So this is called an altitude, and some of them we have the altitude labeled and some of them we do not. So we want to use the values to calculate this missing side. So Okay, so let's do some example problems of these. So for example, number one, you're going to set up a ratio. And this is the angle that I have. Now, this angle, this side length over here is opposite, and this is hypotenuse. So if I write on the top of my paper SOHCAHTOA, opposite and hypotenuse means it's going to be the sine of 73 equals 15 over x. When x is in the denominator, you just flip-flop. So you actually have to do a division problem. So for this one, if you want to figure out what x is, you're going to take 15 and divide it by the sine of 73. Make sure you got that in parentheses. When you work it out, you'll end up with 15.7. And let's look at that as opposed to the second example here. You'll notice that x is going to be in the numerator for the second example that I'm going to do. So if number 3, this is 26, and I have this side over here is opposite, and this is actually adjacent. We don't have the hypotenuse in this case. So I'm going to have to use the tangent of 26 equals x over 17. And you'll notice here that 17 is in the denominator, x is in the numerator, so this is just a simple multiplication problem. You just literally type in the tangent of 26 times 17. Notice that the 17 cannot be inside the parentheses, or you get the wrong answer, you get 8.3. All right, so if it's in the denominator, you're going to divide. If it's in the numerator, if x is in the numerator, you're going to multiply. Let's do a couple more examples. For the second set of examples, you actually have to hit second because you're looking for an angle. So for this set, you have to hit second. Oh, I have it written right there on your calculator. Okay. So this side right here is adjacent to the angle, and this is the hypotenuse because it's across. So adjacent and hypotenuse is going to be cosine. So the cosine of x equals 24 over 55. Again, you're going to have to hit second cosine, so you get that little negative 1, 24 over 55, and then you equal that out. You end up with, what is that, number 7? Looking at my answer key here because I didn't work it out. Number 7, you should end up with 64 degrees. Let's do number 10 really quickly. This is the angle in question. You'll notice that this is opposite, and this is the hypotenuse. So this one's going to be the sine. The sine of x equals 7 over 23. And again, you have to do second sine, 7 over 23. And the correct answer, if you typed it in your calculator correctly, you should get 18 degrees. Okay. Let's step this up a little bit and look at some more problems that have both trig ratio and similar right triangles. So if we're going to do a problem like, let's say, number 13, we can't set up our HLLS, and we can't set up SAAS for these problems, simply because we don't have all the information that we need. In this case, we have degrees and side lengths. So we're going to have to work something else out. Also, you'll notice that the very big triangle isn't a right triangle. So you're just going to have to do trig multiple times to get the information you need. So, for example, the first thing I need to figure out is what is this side length right here so I can figure out what x is. Well, if this is what I'm looking for first, I'll call this question mark, and this is the angle, I'll notice that this is actually opposite, and this is hypotenuse. So the very first thing I have to do is the sine of 48 equals x over 11. And so that's going to be a simple multiplication problem. And you type it in your calculator just like it looks. But please make sure the 11 is not in the parentheses.